Hey, this is Precious Plastic Catalonia. We're gonna wire the shredder electronic. In our case, we use a three-phase motor as recommended. We need a variable frequency drive, which gives us three-phase. Okay, and we want to make this as good as possible. So it means we want to have a fuse or a breaker. This will automatically, switch to off as soon there's a short circuit or anything bad in the system. We're gonna need good cables. We want at least 2.5 millimeter diameter on our cables. Okay, so this is powering our system, but we also use this to wire our motor to the variable frequency drive. We make this all fitting to the amperage which is going for that system. In our case, our motor has around 9 amps. Okay, so we need a wire which can deal with that current, and also a good plug, not any plug. And if you buy them new, they're a bit more expensive, something around €5. You can see we have 16 amps, so we are good. We want a direction switch, forward and backward and stop. Okay. We want a emergency switch, so that's recommended too. And we want a power switch to turn the whole thing on and off. So, and having a look, yes, it's going until 16 amps, so we are fine with that. Now let's move over to the tools we need. Obviously, to wire all these we need a few different sizes of these. The small ones are for the control signals, the big ones for power lines, let's say, and also medium sized if I have. We don't have medium. Okay, doesn't matter. We need also a cable which looks like a ground cable, so this needs to be wired onto the motor or on the chassis of your shredder. Okay. And yeah, for the control signals we take a slightly fewer. It needs to be just something like a half millimeter or 1 millimeter is fine too. We need to solder a little bit, so let's have one of these and some flux. And last but not least, we want to wire our cables best as possible, and usually we use these ones here. That's highly recommended, especially if you want to wire the cable on the motor. So don't skip this one. It's very important. You don't want to have any trouble when accidentally somebody pulls the cable and sets the whole system under electricity. Alright, tools. To prepare cables, you can achieve one like this. Okay, we prefer one of these. It's a good investment, by the way. I don't know how much this is, probably 10-20 euros. And then just the screwdrivers, small, big ones, apply to release the nuts on the motor terminals. You're gonna also need usually one of these. Alright, it's around 7 millimeter or 8 or 10, depends. And to wire or solder, better said, you want to have something which holds our switch somehow in place, so we have it easy to solder this up. Okay. And last but not least, the inverter. This should match basically the kilowatt of your motor. We recommend to buy just a new one to make sure you can also resell your shredder easily. Usually these are relatively cheap, around 100-200 euro, but it enables us to add all these things like emergency switch, direction switch, and also to regulate the speed. So this is a brand from China. We recommend these ones. Cheaper ones will work, but eventually they will fail over time if you move the shredder around or you don't make a good enclosure. So these are the more robust ones. It has 200 safety functions in there, so you're good with that. And very important, you need this one as well. This is your safety guard, okay? You just place it on the table and it will take care, nothing happens bad, okay? So, if you don't know exactly in which way this flow will go through, you can use one of these multimeters. There are also flow testers which give you kind of indication where is flow, right? All of these have this kind of resistance mode. It will beep or not. Anyway, I hope the camera picks it up. Yeah. So it should typically show 1 or -1 depending on this model, but something like that. And it basically measures the resistance. So if I connect the both, there's no resistance, and our multimeter should show 0 resistance. So with that we can measure basically how this works. So at the moment it's on off. Let's try. Yes, it stays on 1. So there's infinity resistance, or a lot of resistance, I'd say. If I turn this on, I should get a 0 again. Voila, works. So this is your way to test components for failure, and this stuff actually works. I hope you bought that all new. Yeah, make sure. So we're gonna use the fuse in ours next and supply our system with electricity. Our wall power goes into the bottom, and when we supply our system, it goes into a main switch, right? And from here we pick it one up and go to the inverter, and we have electricity in our system. So we wire as next the electricity or the power cables in our system. I said you want to use a good cable with minimum 2.5 millimeter diameter per line, and you have to be consistent about this, and you're gonna wire from your plug, right, to the breaker, okay? And then you keep going with this cable to our main switch, which is in the control box accessible, or at the control panel, okay? And from there you power your system to the inverter. Keep going using this cable, it's very important, okay? And do yourself a favor, don't use second-hand cable from the scrapyard. These are usually lying in the sun to get brittle and can break easily, or make sure at least these are still good. If you can cut them easily with a cutter, it usually means yes, they are still okay. But also try bending them and see how porous they are, okay? If there's any sign of porosity, don't use it, go to the shop. It's just €2 the meter. Do yourself a favor, buy good cable if it comes to power, okay? And it also makes sure you can actually sell this shredder at some point later, okay? Because somebody will have a look at this wiring, and you will figure out he has to wire this all over again with good cables. And you can imagine this is going to last a little bit, something like 4 or 5 hours easily, so you don't want to make shortcuts. Get a good plug, get good cable, get also a new breaker and a relative okay power main switch for the control panel. So I'm gonna connect now all these power cables and wire this up. So before you plug these good power cables into any terminal, you actually want to put a little bit of solder or flux on here. This will prevent that movement will cause happening this here. Okay, this can happen quickly. So in order to avoid this, we put just some flux in here to make sure. You can also just use one of these plugs, but I must say for beginners this is can be a little bit tedious and also kind of dangerous if you don't do this right, okay, because it can slip out of these connectors. If you use them, also solder it to make sure that no movement makes them coming loose and out and set your system under fire or electricity. Okay, I'm going to do this now. We have 2 ground cables, one going to the inverter, and we want to ground our motor as well. Okay. Now, most of the inverters, show something like that, U, V, W. This is going to the motor, 3-phase. This is typical. And if you see this symbol here, right, this is where our ground goes, and this inverter accepts single phase and 3-phase, and you just need to block the power in one of these 3 here, R, S, T. It doesn't matter which order, it will recognize automatically what it is. So let's wire this up. Okay, time to wire our motor. We use our good cable, and we want the plugs or good connections at any cost. Try to get it like this. Don't just put a cable around the screw on the motor terminal. You just end up with trouble, or you just cause danger to the others who have to open that or have to change it or whatever. Okay, so this is what you want to have. This goes on the motor and this goes into the inverter. The inverter already has the labels in place, U, V, W, and the motor as well. So our motor is wired up. It went from U to U, or better say U1 on the motor, from V to V, from W to W. Now the good news you can make mistakes about the order of these cables. So in either way, it will work most of the time. And so the default direction can be changed also by just flipping one of these UVW cables. So at this point we have it wired up. As you maybe can see, we also grounded our motor. This is important. If you don't do this, you can get an electric charge, right? And so make sure, especially in humid environments, that you ground your motor as well. So we're gonna fire this thing up. By default, this will be set to 50 Hertz. This is also what the motor wants. You can see this also on the plate from the motor. So typically you just need to press now run, and you can stop it by pushing stop. Most inverters have these two buttons. Okay. If it's not new, you have to go for the manual of the inverter and make sure it's matching your motor frequency. The frequency adjustment is usually done by one of these potentiometers or by the cursor buttons. If you're not sure, you have to consult somebody who is taking care of this. For now we just focus on a new inverter. If I press now run, this should fire up. Make sure your motor can jump around a little bit. I know it won't make much trouble on this glass table here, but if you are not sure, please lock this motor up so you can jump around a little bit. So this is a new motor. And I noticed now that this inverter here has the frequency set to 300 or 400 Hertz. So this is not going to work. So we have to look up now in the manual to set up the main and also the maximum frequency. In the manual, these are the very first parameters you can set. This one here, the camera I hope picks this up. So the very first parameters are about the frequency, the main frequency. These inverters can also supply basically three-phase to spindle motors for CNC machines. So there are motors which go until 400 Hertz. We are looking now for a typical motor setting which is 50 Hertz. So it's going to take me some time to figure. I'm back in a minute. Alright, let's fix this inverter for our motor. So we're gonna look for something like main or base frequency. Let me focus here. It's not really picking up well. Here we go. So let's say these are the very first parameters, are the general parameters of an inverter. So program or function number 3 will set our main frequency. Let's go there. You have to go into program mode. It offers you usually the parameter you want to select. We are at the moment on parameter 4 and we want to go to parameter 3. So we select this parameter and press set. Wow, we are 400 Hertz. So I'm gonna switch this to 50. Voila. Okay, main frequency set to 50 Hertz. Base frequency, this is a bit confusing. I think this should be about the input electricity, which is coming with 50 Hertz. Just for curiosity, we're gonna check this one. parameter 4 is also set to 400. So I'm gonna set this to 50 as well. Okay. Now let's go over to 50. Oops, too much. Okay, let's have a look at the other frequencies. It's also having a parameter here of called maximum operating frequency. Well, let's gonna have a look at this one. It's parameter 5. Shit, this one is also on 400. So yes, this was a factory setting for spindle motors for CNC machines. Oh, it doesn't let me actually set this, so I'm gonna have to cheat here a little bit. So I'm gonna set this to 50 as well. Right. Well, the other frequencies usually you don't need to touch. Don't try, as long it's working. Go step by step. So now let's fire this up. And yeah, I can tell you my motor is spinning. Here we go. So this is a new motor. If you fire those up the first time, they tend to make funny noises. It takes some time, something like 1, 2, 3, 5 minutes, that they are actually running well, let's say. So we just have a slight electricity noise here. This is normal, especially here in this 2 kilowatt range. So also a good check is to touch the motor. Luckily it's grounded, and see this thing is becoming warm. If it's becoming warm, try to flip this UVW cables. This can be also sometimes, especially with cheap inverters, a problem if this is not wired up correctly. But yeah, at first sight, this motor should spin correctly. So we had a motor here, 1480 rounds per minute, and the reducer is 1 to 20, and this is something coming down now to 70 rounds per minute. It looks only 70 rounds per minute. I know that because I saw a lot of video turning on a turntable, so I know that is around 70, but fits. So now it's time to add our emergency buttons and switch, right? We are happy so far with that. Just for fun, we could now have a look at how we adjust the frequency. Now our potentiometer is not doing anything. But to give you an idea, I'm gonna set now one of the next major parameters of such an inverter. If they have a potentiometer, you can use this one, but you still have to tell the inverter, for frequency change, use the external potentiometer. So let's have a look on the manual. Okay, this is going to be source of operating frequency parameter 2, and we can set this to operator board. Simulation amount set embraces board potentiometer and external potentiometer. So so this should be on 1, and the factory setting is on 0, which means operator board. That are the cursor keys here. You want to have it easy. So let's go there. Program number 2. It's on 1. So this is Very confusing. I'm gonna set this now to 0. Oh yeah. Confusingly, it's operator board. Okay. Yeah, Chinese manuals can be a bit confusing. No worry. So about frequencies, yeah, I said this is a motor designed to run at 50 Hertz. You can go down to 25 Hertz if you want, but you shouldn't go below the 25. This motor is running when hot, and also the same applies if you go higher, right? So let's say to 75. That will be kind of the frequency limit. So yeah, let's go on. So since our motor is running, we have power supply. We took care that this thing has a breaker or fuser. It's time to go to this low power accessoires or extensions. We want to have an emergency switch for sure, right? We want to have a direction switch, and the good thing now about having an inverter in place is that these control signals run at a low voltage, around 5 volts or 10 volts sometimes. So this is ideal also to connect to an Arduino to eventually to extend the system for auto reverse or recognized jamming and such things, right? So this is what the inverter gives us, and at the end it's just €100 more for a new one. So it's not a big brainer, right? You want to recycle plastic, be prepared to throw some serious money at this. Okay, let's start with the direction switch. It's a free state button, let's say, or interrupter called, and what it wants is a baseline. This is our ground. It comes from the inverter, and two control signals. This would be usually a plus, right? So if I connect this to the inverter and so let's have a look at our input and output terminals of this inverter. And as said earlier, many of these can have different functions. You can program this, and we are looking for reverse and forward. So if I connect, for instance, reverse to DCM, it will set the inverter to forward rotation, and it also activates the motor that way, okay? And reverse or forward, just needs to be connected to DCM. If you look this up in the manual, it also says DCM, common terminal of digital and control signals. Now when there's another one, it's called ACM, common terminal of analog and control signals. So it could be one of these. The analog is usually used for another potentiometer on this inverter. So we're gonna try it both. So we take our switch and we remember now it's kind of reverse. So if I say 1, the lower will be, these both here will be connected to each other. So let's pick this up and wire this. Okay, here we go. I power this. And we're going to have a look, but we have to eventually set something in the parameters to activate this very external control. Okay. Right. Now what we want is actually that as soon we activate forward, that this thing also runs forward, and this will be actually the source of run command. At the moment the factory setting is on 0. You see operator. The operator means it's the panel of the inverter. Okay. But in our case it's an external switch, so let's have a look again. Yes, if we set parameter number 1, source of run commands on the external terminal, then we should be fine. Let's do this first. Program number 1 is on 0, which is this panel. We set it to 1 for external. Voila! Our motor starts spinning. Don't worry about this, it's just 5 volts. So it's spinning, and I set this to nothing, and it stops. It takes some time. Okay, I can see this also on the frequency display here on the inverter. Voila, it's on 0. This is what we wanted. If I activate backward, okay, fast switch forward, okay, so it takes a long time, but this thing is breaking down, okay, so let's take care of all this. So a common or very typical major parameter of an inverter is the acceleration time and also the deceleration time. There are usually for each type of acceleration 3 timing parameters. We usually just set the first one, and if I look at this on the camera, hopefully picks it up. If not, I'm just gonna read this for you now. Parameter 14, acceleration time, can be set between 0.1 until 6,500 seconds. There is no factory setting yet. I don't know what a star symbol means, but let's just have a look. Parameter 14. Okay, let's go there. It's on set on 20 seconds. Yeah, well, this is really bloody long. I want to set this to something more speedy. We don't want to have these 2 seconds, so let's set this to 3 seconds, right? Okay, parameter 14 for acceleration time is set. I'm gonna head over now to deceleration, the braking time. This is right to the next. So parameter 15 in our case is also set to 20 seconds. Yeah, well, this is really long. Let's be nice to our motor, otherwise this thing jumps, right? And we have to break down. So I set this to 4 seconds for now. Okay, let's try this. So 3 seconds we say for acceleration. Yo, this seems to work. And I go back 4 seconds to slow down, another 4 seconds to speed up again in the other direction. That's fine with me. We can try lower. I can't recommend anything below 2 seconds. It's also consuming a little bit more electricity than needed. Okay, so our direction switch, yeah, is wired up. This can go later on in the control panel. Now let's head over to our next button, which is the emergency button. So after trying this now, turns out this one, yeah, doesn't work as we want. The emergency stop function wants it exactly in the opposite direction. So what you can do now is, since this is all about opening and closing, or connecting, disconnecting to cables, what we can do is we interrupt this shared ground signal and put this one in between, right? So this should work. Let's do that. Right, so I picked the ground signal, place this one in between, okay, and let's see. Right, okay. So this one is open. And change direction. So now, voila. Okay, this is it. I release it again. It goes on. Fantastic.